So far, we have been dealing with programs that are done in a pooling method, meaning everything is done on your main function, main thread, where you analyze the state of a button or an LED or whatever it is, and then you execute whatever action is related with that. But now we're going to cover another way, which is interrupt-driven applications. We're going to start using interrupt routines and also a mixing of these pooling and interrupt-driven applications. There are limitations when you're just doing your pooling method. As you probably noticed last week when your homework assignment, you probably had you're monitoring two buttons, and while you're monitoring one button, you could not see the state of the other button. So let's see how can we use this interrupt-driven technique to solve our issue. Exceptions and interrupts. Let's go over a typical system. You have your processor running, and there is a peripheral that requests an interrupt. Your main program is going to step to a handler mode. It's going to handle the interrupt routine, and then it's resuming back and run the normal code. What is the common terminology that we need to be familiar with? Interrupt requests, non-maskable interrupts or NMIs. These are special interrupts with highest priority that they cannot be disabled. For example, watchdogs or brownouts detectors. We have handlers or interrupt service routines. This is code that is executed when an interrupt request is generated. Then you have nested interrupts. It's just a way to divide interrupts and exceptions into multiple levels of priority. And then we have the nested vector interrupt controller or NVIC, which is a programmable hardware inside of your microprocessor that manages or handles the interrupts and exceptions requests. So how does the NVIC interact with your processor? This is a typical way of NVIC to interface with the processor. You have the peripherals connected to the NVIC, and then the NVIC is going to use those interrupt service routines to interface with, or the processor is going to use those interrupt service routines to interface with the NVIC. This is the vector table where you have access to the memory positions where you know which interrupt vector was generated. And this is what is happening if you recall the processor modes. If you are working on this thread mode, whenever there is an execution of an exception or interrupt, you go to this handler mode to handle those exceptions. And then the concept of stacking and unstacking. If you have your main program running, and if there is an interrupt routine that is generated, there is a little bit of time between this interrupt being generated and the code entering the interrupt service routine. During this time, the program is doing something called stacking or a context switching. Is switching all the variables from your main thread to your interrupt service routine, doing those push and pop assembly instructions. And then you enter your interrupt service routine. You are responsible to clear the flag of that respective interrupt. Once you're done, you unstack, you do that pop to go back to your main execution thread. There is another concept called tail chaining, which is pretty cool. So if I have two interrupts happening, let's say I have interrupt A happening here, and then I start handling that interrupt. But let's say that during the period that I'm handling that interrupt, there is another interrupt from, let's say, handler B that is generated during that time. A cool feature is that the program does not need to exit this interrupt service routine and go back to your thread main and then do a stacking again to enter the handler B service routine. You can actually go from one handler to another handler. That accelerates the process a lot. And then at the end you do the unstacking. But what happens if you have a late arrival? So now we have two interrupt routines, one with lower priority, another one with higher priority. we have the lower priority happens first, and then we have the higher priority happening before you actually enter the handler of that lower priority interrupt routine. So what happens? Well, again, ARM platforms are smart enough. You're not going to waste time doing the stacking and unstacking. If I'm doing the stacking, I'm using the NVIC. I know that handler B as higher priority is going to handle that one first, and then handles the lower priority thread or interrupt routine, and then unstack and resumes the program. Now, if you have, let's say, this interrupt of higher priority happening a little bit later than this, while if this was your handler A, and now this interrupt will happen, let's say, over here, then you need to wait until you finish your handler A, and then you go and you handle your handler B, and then you unstack, and then you leave. So interrupt routines are cool. They're going to accelerate a lot your program because you can react faster to inputs, for example. But there are also some constraints, which is the stacking and unstacking, that they can limit your real-time ability of your program. So you need to be aware of this context switching timing.